In this video, we continue with our discussion of the hash table data structure. You should have watched the first part of the video and you should have created this project. I have a main package with a lowercase m, and I have a main class. I don't have any auxiliary classes or secondary classes or extra classes because I plan to do everything in the main just to demonstrate hash tables at this point. We created an object of type hash table called MyTable. It is a parameterized data type that takes a key and a value. The key is a string, the value is a string. We can be more complex later on, but we're certainly permitted to use basic elementary data types as our K's and our V's. So I'd like to add an element to my hash table. So I type MyTable and then dot. It brings up all of the available methods. The first thing I'd like to look for is the method called add. I don't see add. The first method alphabetically is clear. What else is in here? Can I scroll through this list? I find put. Eventually then, as you get more experience with these data structures, you will memorize some of these names. You probably won't memorize all of them, but I found one called put. That appears to be what I want. Of course, we could go on the interweb and we could search for how do I add something to a hash table. If we're really not sure what to do, we could find some example code, or we could be a detective and we could just look through this list of methods and hopefully find one that appears to be correct. The put method requires 2 arguments, which appears to be in line with what we want to do. We're going to provide a key and we're going to provide a value, and then the hash table class will hash the key, and at the location of the hash store the value. We don't care how it works, we just care that it works. So let's make our key Smith. Let's make the value Mary Smith, 123 Main Street, Cincinnati, Ohio 45000. That's all in a string. Our key then is Smith in quotes, and our value in quotes is Mary Smith, 123 Main Street, Cincinnati, Ohio, 45000. You can see the key then is quite a bit shorter than the value. It doesn't have to be, but it makes sense to generally do it that way. If your key is longer than your value, you may want to rethink how you're modeling your data. And that puts a value into the hash table. Of course, we'd like to generate some output, and I'd like to know how many elements are in this hash table. There should be 1, but let's print something out just to make sure. And if I do MyTable dot, is there a method I can call to tell me how many elements are in the table? Well, there's a method called size, returns the number of keys in the table. Now there may be multiple values at a key. That's beyond our scope right now, so don't worry about that. I'm not going to ask you to do that, and I'm not going to ask you to explain how it's possible to have multiple values for the same key. Obviously in SQL Server, in your database experience, it's impossible to have multiple values for the same key. You can only have 1 row per key, and we're going to assume that that's how our world is going to work, so don't worry about that. And we can print out the size. And hopefully when we run this program, it prints a 1. Hooray! We added 1 element to the table, and it printed out the size of 1. So we successfully added something to our hash table. Could we do the same thing with an array list? Kind of, but we wouldn't have the key. We would just have the value stored in the array list. Can I put another element in the hash table? Of course I can. Let's just change the key a little bit. Let's put another person into our database. John Jones lives at 124 Main Street. They live right next to each other, or maybe in the same building, who knows. And just print the size again. The size should go to 2. Hooray! We've added 2 elements to the hash table, and we have printed the size of the hash table. Can I search for a value? I'd like to know what the key or what the value is for the key Smith. So how can I look up the V for K equals Smith? I'm using V and K because that's the terminology that Java uses to represent keys and values. So I am going to ask you to figure this out. Go look it up, experiment a little bit, stop the tape, and see if you can figure out how to write a line of code to look up the value associated with the key Smith. And then once you've done that, start the tape again, and we will do it together. We're back. You should have by now taken the time that you needed to figure this out. Now I know that the value is a string because I declared in that parameterized data type V as a string. So I need a string. I need somewhere to store that value that I'm going to look up. And I can probably say something like my value equals MyTable dot. And can I look through this list and find a method that might do a lookup for me? You may have gone online, you may have searched on Google to find out how to do this, and that's great. I see something called get. Returns the value to which the specified key is mapped, or null if this map contains no mapping for the key. That looks really good. So it's going to do a lookup by key. And I know that my key is Smith. And I know that if I call get, it's going to look up the key as Smith and return the associated value. And then I hopefully can print out the value. And that should be the address of Smith. And that worked. So I called the get method to look up a value in the table. Something else that we do quite often with the data structure is iterate over all the elements in the data structure. And that iterating process is something where we ignore all the keys and we just ask for each value one at a time. We find ourselves having to perhaps do something to each value, or print each value, or store each value somewhere else. So instead of looking up by key, we just step through each element one at a time. Now, if this is something you don't know how to do, I would recommend that you go to the Google and search. I'm going to search for iterate over the entire hash table. I get 545,000 results, and I will read them all. No, actually I won't. I will look for something that looks like what I need. The very first hit is called How to Iterate Through HashTable. It's a site called Java 2 Novice. I don't know anything about that site. I will click on the link because it looks reasonable and Google thinks it's important. I assume it's not going to attack me. And I could read through this. If I'm in a hurry, I could skim through the code, and you can see that a lot of the code is just building an example, which is what we did in our code. But the real part I'm interested in is the for loop. So we're using an enhanced for loop. We don't have an increment step. It doesn't look quite like a for loop, but it's a very popular construct that we're going to use a lot when we write code. I'm really actually interested in these 4 lines because I need the KeySet. So I can actually copy that. Now I have a working example, but my variable names are incorrect, so I may have to do some editing. I think this is a good way to go, however. Copy those 4 lines of code and paste those directly into my project. And as you can see, I get some squiggles, but it doesn't look too bad. I think I can fix this. Let's take them one at a time. Remember, if you have a problem, always take the errors one at a time from the top. Generally, if you fix one at the top, it fixes a whole bunch of others down below. So don't start picking and choosing errors. Pick them top down and fix them one at a time from the top. The very first one, as we can probably guess, is it doesn't know what a set is, but it's happy to bring in java.util.set. Now, as you get better at this and you have much larger projects, there will be many things called set. There will be many things with the same name, but they'll be in different packages or different classes. So you have to be more careful, but at this point we can be pretty sure that it's the correct set. The second error, it doesn't know what HM is, and we use something called MyTable as our hash table. So we'll paste that in there. And MyTable supports a method called KeySet. If you hover over KeySet, it returns a set view of the keys contained in this map. Okay, just translate in your mind the word map to table. It still works. And then we got to fix the HM down there. And we can see now that our code has no squiggles, which means no news is good news. At least the syntax is correct. The logic may not be correct, but the syntax is. And this is making me nuts. I'm going to put spaces in here. I just think it's so much easier to read. Just personal preference there, no problem. All right, those 4 lines of code should let me iterate over the hash table, and the print statement inside the enhanced for loop prints out the key values and the corresponding keys that go with them. And let's see what happens. There it is. Value of Jones is, so it prints out the key and the value associated with that key. Value of Smith is, prints out the key Smith and the value associated with that key. So that looks very good. We were able to iterate over the entire hash table. Since we only had 2 items in the hash table, we're not really sure what order to expect, and I will tell you that you are not guaranteed any order, meaning that when you put things in the hash table, the way you pull them back out again over the iterator is not a guaranteed order. You just have to take what you get. There's no sorting going on. So I'm going to put in a third item just because I'm curious. I'm going to put Control C, Control V. I'm going to put Andrews, and I'm going to say Andrew Smith. I'm sorry, Mary Andrews. And let's put in a fourth item. Let's put in Zebra. And let's give them different addresses, 125, 126, just to make ourselves happy. We added an element at the very alphabetical top of our conceptual list and an element at the very alphabetical bottom. Again, that does not mean they will be stored in that order, but I'm very curious what will happen when I print this again. I'm going to move those two lines, and again, you should be following along. If you have to pause the video, please do so. Now we have 4 elements in the list. When we execute the for loop, we're going to get all 4 elements out of the list, but we're not guaranteed that they will be in any order. Let's see what we get. It appears to be in insertion order. In other words, Smith was inserted first, and then Jones, and then Andrews, and then Zebra. But you're not guaranteed, so do not assume that it is imposing any kind of sort order on this iteration. All you have the luxury of is looking up things by key. You do not have the luxury of sorting them by key. That's where it differs from a database. Okay, things are not stored in any kind of sorted order. You are not guaranteed that.